Hey folks, MoNaCo here. It's homework lecture video 2, Physical Behavior of Matter. We're focusing on the phases of matter today and how they have different properties at the atomic level. And we're going to get into those definitions of what those are. Why? Why do we need to do this? We have learned about phases already. What more do we need to know? Well, the phases, we need to start thinking about them at the atomic level, what the particles are doing, and how heat and energy can cause changes in those. Okay, everybody knows what solids, liquids, and gases are, but we're going to go into deeper depths about how energy changes a solid into a liquid and a liquid into a gas. So we got to think about the properties of those phases. Now, we have talked about STP briefly before. It's there mostly, everybody sees STP and freaks out, loses their minds because they don't know what it means. Well, it's reference table A, and it's talking about standard temperature and pressure. We chemists had defined standard temperature and pressure as 0 degrees Celsius and 1 atmosphere of pressure. And just so that all these notations that we're going to be teaching you make sense, these are the notations that I want you to know about. Notations. Everybody knows about solids, liquids, and gases, but the way we draw them on paper is very important because we put them in parentheses, S, L's, and G's for the solid, liquid, and gas. Plasma gets no notation because we don't talk about that in chemistry class so much. And then the other, it's not really a phase of matter, but this is a type of notation that we see sometimes, is an AQ. This means you've taken a solid or a gas and dissolved it in water. It's not really a type of matter, but it is a phase of matter. So that's another notation that you might need here. So if we take our image here on the right-hand side of your notes and we put our notations in, S for solid, G for gas, L for liquid, we notice that the names that point in different directions and different colors here between the phases are kind of familiar. Liquid to solid, obviously, we know that is solidifying. We also call that freezing. When we take a solid and turn it into a liquid, we call that melting. Okay, that's pretty simple, straightforward. When we take a liquid and go to a gas, we call that vaporization. Okay, and we take a gas and go back to a liquid, we call that condensation. Now, the words that you might not be familiar with, and they're brand new and important to this unit, are deposition, which is when we take a gas and turn it directly into a solid, and sublimation, when we take a solid and go directly into a gas. So I want you to draw your arrows in here to represent those transitions. The third and final vocabulary term that I want to put into like this area between solid and liquid is called fusion. We'll investigate that further in our subsequent homework notes, but there's a lot of vocabulary and terminology that are focused around these phase transitions that you need to write into your notes here. So make sure you make all these annotations on the imagery in your notes to follow along as to what I just did. Now, we're going to get into the second part of this page here, which are the properties of solids, liquids, and gases. Let's start on solids with the shape. Definite shape. Solids have definite shape and definite volume. You look at it, it's a square, it's a triangle, it's a circle, whatever it is, it has a definite shape. Definite volume means you can find it. The particles in solids are vibrating around a fixed point. So if you think of like a bunch of army soldiers standing in a row, they would represent kind of a solid because each one might be breathing in and out, but they're not moving side to side, front to back, left to right. Density. These are the highest density phases of matter. Because the atoms are packed into a small area of space, they have very small distances between each other particles, and we call it high density. Intermolecular forces for solids are strong. They are solids because they have strong intermolecular forces. Their particles are attracted to each other, like in this picture, and they don't want to move around because they have such high forces of attraction between those particles. So that is a solid. A liquid represents a progression towards another end of the spectrum here. A liquid takes the shape of its container, and therefore it has a definite volume. Now, the particle movement are liquids vibrating around moving points. So these are kind of like a jar of marbles rolling around, the particles in a liquid. They have a medium density. They still technically have a high density compared to, the other phase of matter that we're about to go into, but it is a lower density than that of a solid, typically. And typically the intermolecular forces of attraction are strong, but they are weaker than those of them in a solid. So this is representing a spectrum here. Last phase of matter we'll go into is the gas. They take the shape of the container. Just think of a balloon. You blow up a balloon, the gas you blow out of your lungs fills the shape of the balloon when it's all finished. There's long balloons, skinny balloons, shaped balloons, whatever. But the volume, again, as you know, takes the volume of the container. It fills it all up. And you can measure the volume of a balloon, so you can measure the volume. And although the shape isn't definite, you can kind of measure the shape of a gas sometimes if you put it under certain conditions. Particle movement in the gas, they're free to move around. I like to think of these as like billiard balls that have just been hit by the cue ball. They're moving kind of in straight directions all over the place. Kaboom, kabow, kabang. They're all over the place. These have very low densities. And if you look up their values on table S, they're on the order of, tenths, hundreds, thousandths of a gram per milliliter. They're very low density. And they have very weak intermolecular forces of attraction, which is why they're so thin. You can move through them in the classroom. You're moving through gas all day long as you walk around our planet. So they have very low density, weak intermolecular forces. And at this point, we've kind of covered the basis of those new terminologies about the phases of matter, how they look at the atomic level, how their intermolecular forces are related, and how we have different terms for the transition between the different phases, like sublimation, deposition, vaporization, condensation, melting, freezing, and fusion. Those are all the terminologies related to those phase changes. We have a CASTLE learning quiz for you titled Phases of Matter. It's 10 questions to reinforce this topic. And thank you very much for your time.